Let's have a look at some Eulerian and Hamiltonian questions. These are wordy questions and sometimes tend to confuse students. A graph has 6 vertices and 7 edges as shown in the diagram below. Now always skim read your questions and try to eliminate them if possible, and work with a few. That's a lot easier than looking for the right answer in all the 5 options. So the simplest one I always find to work with is the Eulerian trail. Now for an Eulerian trail, you need to have at most 2 odd vertices. Now if you look at the degree of the vertices over here, you can see that there is F with degree 1 and E with degree 3. So definitely it is an Eulerian trail. So that leaves you with C, B, and A as options and helps you eliminate D and E. Now, if you look at the fact that not all are even, so here you need at most 2 odd degrees. And for Eulerian circuit, you need all even degrees, which is not possible. And so that takes away option 1 and takes away option D, which we've already eliminated. And now let's look at whether a Hamiltonian cycle exists. Now I have found that if your network graph given has cycles in it, for example this one and that one, it is not possible to have a Hamiltonian cycle, because if you wish to start at a point and come back to it, for example here, 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 and it's not possible always to come back. Okay, you may have to visit a vertex more than once. So Hamiltonian cycle is not possible. So let's kick that out and kick that out. Now that implies it leaves you just with option B. Now let's check and see if a Hamiltonian path is possible here. Clearly we can see wherever we start from, we can actually touch every vertex once. So a Hamiltonian path is possible. And that confirms our option B. Let's look at this network graph given. Consider the following 5 statements about the graph above. The graph is planar. The graph contains a cycle, contains a bridge, contains an Eulerian trail, and contains a Hamiltonian path. And how many of these statements are true? In order to answer this question, you have to have a good idea as to what each one of these concepts are. Now, the graph is planar. So when we hear the word planar, it reminds us that it's a graph with no intersecting edges. Okay? No intersecting edges. And clearly, we can see in this graph, there are no intersecting edges. The graph contains a cycle. This one is a cycle, and that one's definitely a cycle. Contains a cycle, true. The graph contains an Eulerian trail. Now an Eulerian trail means at most 2 odd degree vertices. And so now let's put down the degree of each of these vertices. This is 2, this is 3, this is 3, that is 2, that's 3, and that's 1. Now if you look at the degrees of these vertices, you can clearly see that there are more than 2 odd degree vertices. That's that one, that one, that one, and that one. So that is not true. Sorry, I missed the bridge. The graph contains a bridge. Yes, this one is a bridge because if you remove that particular edge, it disconnects this point here from the rest of the graph. The graph contains a Hamiltonian path. So let's see if the graph contains a Hamiltonian path. Wherever we start, we can go and visit every vertex once. So we can clearly see over here that we have 4 statements which are true, and the answer is D.